Hi there. So in this section, I'm just going to give you a little bit of a preview of the algebra behind working with functions and just a brief preview of the composition of functions. But this will hopefully take care of the algebra behind the scenes so that you can focus on the new concept in your 171 class, which will be the composition of the functions. Okay? So here in example 1, they just want us to simplify these expressions, and these should look very familiar to you in terms of, here in letter A, if I want to simplify this, hopefully you're recognizing that there are like terms here. I've got x's that can be combined, and I've got numbers that can be combined. And that's the idea here, is I just want you to simplify it down to lowest terms. So here in example 1, letter A, if I combine like terms, 6x and 4x will combine to give me 10x. Combine my numbers, a positive 8 and a negative 2 will give me a positive 6. And then that would be your final answer. You've got a letter term, and a variable term, and a numerical term. Okay, that's your final answer. In letter B, hopefully you recognize here that I've got a parenthesis sitting back here, and I've got a minus sign in front of that parenthesis. That minus sign, remember, retreat that as a -1, and that -1 then needs to be distributed through that parenthesis. So my first step here is to take and bring down that 6x plus 8, and then I'm going to take this -1 and distribute it through. So -1 times 4x, -4x, -1 times -2, positive 2. Now we're right back where we were in letter A. Let's combine like terms. 6x minus 4x, positive 2x. Positive 8, positive 2, give me positive 10. Final answer. Oh, I'm going to cut that a little short there. 2x plus 10, final answer. Letter C, I'm taking these two expressions here and I'm multiplying them together. So I've got a 2 term times another 2 term. They're referred to as binomials. I'm going to multiply here. Typically when you're multiplying two binomials like this, we utilize the FOIL method, but you use whatever works for you. FOIL stands for, is an acronym that stands for first, outside, inside, last. And so you multiply your first, that means the first terms of the parentheses, so 6x times 4x, 24x squared. Outside, so the outside terms of your parentheses, 6x times -2, -12x. Inside, the inside terms of your parentheses, 8 times 4x, a positive 32x. And then last, the last terms of your parentheses, so the 8 and the -2, 8 times -2, -16. And then lastly, do one last little cleanup here. You'll notice your middle terms are like terms. We combine those. Final answer then, 24x squared plus 20x minus 16. And that would be our final answer. And then here in letter D, we are taking expression up top divided by the expression on the bottom. Hopefully you recognize here that the expression up top as well as on the bottom, they both have like term, or they both have a common factor. That's the best way to say it. They both have a common factor. And we ask ourselves, well, up top, what's a number that goes into both 6 and 8? Hopefully you agree. A 2 will go into both of those. I'm going to factor out a 2. And so when I do that, when I factor out a 2 of that 6x, 2 times what gives me 6x? Hopefully you agree with 3x. Plus 2 times what gives me 8, and that would be 4. On the bottom, we're looking for a number down here that will go into both 4 and 2. Hopefully you agree, that would also be a 2. So I'm factoring out a 2 out of the bottom. So 2 times what gives you 4x? 2x. It's not a plus, is it? That's a minus. Minus 2 times what gives you 2? Be a 1. Now from here, it's legal because I've factored this 2 out on the top and the bottom there, and it's outside like that. It's legal for me to cancel out those 2's, and now my final answer, ultimately reduced here, 3x plus 4 over 2x minus 1. That's our final answer. That's what we're looking for there. Just reducing, simplifying. Okay. Now in number 2, we're simplifying just a little differently. Just want to make sure that we remember our rules of adding, subtracting, multiplying, and dividing fractions. Okay. So in letter A and B, anytime when you add and subtract fractions, as long as you have the same common denominator, you keep that denominator and just add the numerators. So up top, 6 plus 18 is 24 over x. Final answer. Letter B, subtraction works the same way. You keep that denominator when it's the same common denominator, keep that denominator, and just do the operation up top. So 6 minus 18 will give me -12. So negative 12 over x, final answer. The rule for multiplication, when you're multiplying two fractions, you just multiply straight across. So up top, 6 times 18, 108. On the bottom, x times x, x squared. And then that would be your final answer. And then the rule for dividing fractions, copy the first, change it to multiplication, and flip the second. Copy, change, flip. I've heard people say keep, change, opposite. Means the same thing. But copy the first, change to multiplication, and then flip the second one. Now from here you can do what we just did on that previous problem where you just multiply straight across and then reduce. It's also legal to cross cancel anything that they had in common. I can show it both ways. So if I just go straight across at this step, then 6 times x, of course, is 6x, and on the bottom, x times 18, we would write that as 18x. Now I can reduce that. These x's can go away, so just get a different color here to emphasize it. These x's will go away. 6 and 18 can also be reduced. We could divide them both by 6. So 6 divided by 6 would give me 1. 18 divided by 6 would give me 3. So 1/3, final answer. Going back to how it was written here, these x's are diagonal from one another, so you could cross those off. 6 and 18 are diagonal from one another, so you can reduce here. 6 divided by 6 is 1. 18 divided by 6 is 3. And then when you multiply straight across, when these canceled out, when these x's canceled out, they became 1. So 1 times 1 is 1, and on the bottom, 1 times 3 is 3. So you get there either way you do it, okay? In number 3, they want us to answer these questions and simplify our answer. So in letter A and letter B, you're just finding f and g evaluated at this particular value. So I'm evaluating f and g at 3. So we've done this before. Go to your f function, everywhere you see an x, plug in 3. Go to your g function, everywhere you see an x, plug in 3. So you might want to pause the video, try both of those, make sure you're tracking. And then C, D, and E is where the new material is going to come into play. So if I were finding f of 3, I'm going to my f function. Everywhere I see an x, I'm plugging in 3. So I have 3 squared plus 2 times 3. And then just work a little math here. 3 squared, of course, is 9. 2 times 3 is 6. Add those together and we get 15. So we just found that f of 3 is 15. Let's find g of 3. Go to my g function. Everywhere I see an x, plug in 3. So I have 3 minus 1. And of course, we know 3 minus 1 is 2. So we've now found f of 3 and g of 3. Got those checked. Now you'll notice a little bit of different notation down here in letter C and letter D. You'll notice how they have f plus g of 3 and f minus g of 3. All that's really just a shorthand way of writing f of 3 plus g of 3. Or over here, f of 3 minus g of 3. And since I've already had you find f of 3 and g of 3, and we've already found those values, we can just plug those values in down here and come to our answer much quicker. We now know that f of 3 is 15, plus g of 3 is 2. So adding those two functions together, we have 17. Final answer. You would repeat that process there in letter D. F of 3 we know is 15. Subtract your g of 3, which is 2. 15 take away 2, 13. Final answer. So all that I'm asking you to do down below in letter E is say, okay, well, what's f plus g of x? So let's just break this up. Remember, this means f of x plus g of x. So in place of f of x was given to you. We'll put x squared plus 2x. In place of g of x, we'll put what we know g of x to be, x minus 1. Put that in parentheses like that. Now from here, we'll just combine like terms. So x squared, 2x plus x, that'll give us 3x. And we'll have our minus 1. And that would be our final answer. That is your f plus g of x. So when you see that notation in your 171 notes, that's all that it's going to mean is that we can just split that up, okay, into two separate pieces, okay, into something that you really are already good at working with, okay. right, let's flip it on over to the next page. At the top of the next page in example 4, you're given two functions here, f of x on the left, g of x over here on the right, and they want us to use our graphs to answer these questions. So I'm going to do a couple of these with you. So let's look at letter A. Letter A says it wants us to find f of 14. So remember, when we say we want to find f of 14, this 14 this is like shorthand for f of x. So we're saying when x is 14, we want to find the y value. So we want to go to our f function, this is the one over here on the left. When x is 14, the y value is positive 10. That'd be your answer. Just plucking it off the graph, okay? All right, let's look at letter B. F of 6. What do you think that would be? If you let x equal 6, then the y value is positive 2. That would be your final answer there. And we'll skip over C. I'll let you check yourself with the answer key. Let's do letter D. I want to find g of 6. So the g function, that's the graph over here on the right, g of 6, so you're letting x equal 6. What's your y value? X is 6, y value 14. Final answer. Then I'm just going to scoot down here and let's look at f and h. All right, in f, I'm asking you to do f of 6 minus g of 6. Well, if you look at letter B, I already had you find f of 6. That was 2. And g of 6, I just had you find that in letter D there. That was 14. And then just subtract those. 2 minus 14, that'll land you at negative 12. Final answer. So that's all that you're looking at there. In letter G, you're just multiplying the two values. Let's look at letter H though. Letter H is a little different. Letter H is a composition of functions. It's read f of g of 6. When you see a composition of functions like this, the rule is that we're going to work from the inside out. So you first want to find out what is g of 6, which we've already found that. G of 6 is 14. So we can replace g of 6 here with 14. Now it says go to your f function. Everywhere you see, well, where your x, you go to your f function, and where x is 14, you want to find out what the y value is. And so we've done that already. When x is 14, the y value is 10. Final answer. Okay. So I want to pause the video and go back and make sure that you can do C, E, and G. Check yourself by the solution key. Make sure you're tracking. And then I'm going to scoot down here. Actually, number 5, I think that you would be able to follow very well from the solution key that I posted, so I'm going to let you do that one. You're just substituting in and finding those function values. And then, let's see, down here in example 6, I think I am going to let you, well, I think we'll do one more together. If you feel good about it, you might want to pause the video and try it yourself. And then you can, if you got stuck, you can put it back on and hear me talk through it. Okay, so let's look here at letter A. Letter A wants you to find g of 4. Go to my g function. Everywhere I see an x, plug in 4. So that would be 4 plus 5. So that's going to give me 9. So we know that g of 4 is equal to 9. Final answer. And you can just write 9. You don't have to write g of 4 equals 9. You could just write 9. Now B says go to your f function. Everywhere you see an x, plug in 9. So f function is the square root of 9. So that's just going to give us 3. So f of 9 is equal to 3. That's our answer. Now letter C is another one of those composition of functions. Like we just said a minute ago, we're going to work from the inside out. Find g of 4 first, which we did already. G of 4 we know is 9. All right, so that right there became 9. So now I'm finding f of 9, and I just had you find that. F of 9 is 3. How we step this up is, you know, in class in 171, in your 171 class, is that I'm not going to ask you necessarily these two pieces each time. Okay, you would have to find g of 4 for yourself, and you would do that behind the scenes and get your 9, and then you would take that 9 and plug it into your f function, and you'd still get your 3. This is, you know, here in the 071, I'm just trying to get you kind of accustomed to where these pieces are coming from, okay? And hear a little bit of the terminology before you hear it in class, okay? All right, so looking over, or before you look at it online. In letter D here, find your f of g of x, so work from the inside out. G of x is x plus 5. Now go to your f function. Everywhere you see an x, you're going to plug in x plus 5. So your f function is the square root. X will be x plus 5. And that would be your final answer, that f of g of x would be the function, the square root of x plus 5. Key for working with these composition of functions will be that you work from the inside out. And in the 171 class, we'll add one more piece to that, which will be the domain. As I told you, domain does not go away. All right, let me know if you need anything. Thanks a lot. Bye.